So welcome everybody. This presentation is called Adding Location to HEIF, actually, with GeoHEIF, and it's Nuria that is going to do the presentation for us.
Both. But this is an introduction to the HEIF format. It's a format defined by moving pictures expert groups. It's a modern and multi-part data encoding format that can support georeferenced imagery when we introduce the GeoHEIF extension. The GeoHEIF was defined during the testbed 20. And it's a candidate specification. It's not at this moment, it's not a LCA standard, but we hope that will be. GeoHEIF basically defines the properties to including the georeferencing information in the image items. These capabilities make it's possible to include the georeferencing information in a GIMI, as GIMI is the profile of a HEIF standard. This lightning talk will present an overview of how GeoHEIF enables GIMI and HEIF to support the georeferencing information.
Yeah, we can do what we call a pimpinela. Some people can still remember the group, I believe.
I can continue.
Okay, so GIMI is the result of an effort to replace another format that seems that is very popular in the US administration, that is called native. And what is good from the approach is that this GIMI is a more modular format that also includes what is necessary to increase performance in the same way that we can do in COG. That means it has tiles and overviews. It may include still images, multi-band images, multidimensional DQ, motion imagery, audio, and some other elements to accompany the previous ones, like security markings and timing information, and rich geospatial data. And in this geospatial data, you can have the georeference. It's based on this list of standards that you are seeing here. I believe we have a slide here where you can see it better. At the very bottom of the screen, you have the BMFS. That is, in essence, the standard that defines the container format. So how you divide your file in different things that are called boxes, and in those boxes you can store different things in it. In the HEIF format, in the greenish area, you can see how to use this container format to use MPEG form kind of formats. So you can store multimedia files and compressed image and other elements like that in it. This is not the only way. MP4, for instance, does a similar thing, and CGP is also doing similar things. But HEIF doesn't define any particular encoding. And this is something kind of weird, but we became used to that in terms of when you try to use this video format in our computer to see a movie. Sometimes the extension is quite familiar, but the actual player says, I cannot understand. And we got familiar with this idea of codecs that are actually the internal formats that are kind of even more important than the extension of the file itself. So you can have this EEC or for images, the rich people that has an iPhone in their pockets. I do not. Normally, they distribute this kind of format, what is very annoying for the ones that we don't have it. You can have this ABC that is one of our objectives, reading this during this testbed. You can have JPEG 2000, or you can even have information in some kind of a raw format that means that it is uncompressed, or even if it's compressed, is in a non-degradative way. So the big question is, okay, if all of these existed, why GIMI brings as an extra thing? No, now we were discussing that for a while, even this morning, because we have been working on that, but still it's kind of difficult to understand that because of this layering structure, no? And the GIMI brings not many things. It brings a way to have global identifiers of each of these relevant boxes, not all of them, but the important ones. It brings a way to use international atomic time instead of the normal vulgar clock time. What I never understood why is necessary, because this gives us a nanosecond precision that is really important for the GPS constellation, for instance, and so on, but it's not really important when you store an image in a file. But anyway, it brings that functionality. It also adds security markings and the content identification I already talked about.
And also that it's restricting the codecs that you can use in the file.
So in some sense, it's an extension because it brings new things, and in some sense, it's a profile because it restricts things. There is, of course, a way suggested to how to include metadata. And one of the elements of this metadata is the actual georeference, and this is what we want to discuss now. Actually, we believe that the georeference could be something kind of independent with all these things, and we call this the GeoHEIF. And this is the group that we created in the OpenC to do the standardization. This is more or less the same way of seeing this, but you can see more layers there on top if you want. Nuria designed this slide herself, and she will tell us.
Yeah, I want to try to describe also the tension situation between all these standards or future standards. No, these are similar aims, but not the same. No? For example, GIMI is more focused on imagery, metadata, identity, and security, and also semantics. And while there is a seek-optimized if that is more efficient, I focus on the efficiency for browsing. It's a format similar to the cloud-optimized GeoHEIF, but for if. And there is also the concept of the data cube and the coverage implementation schema, no? That is more focused on the multidimensional structure and analysis, and also the georeferencing. And then in GeoHEIF, we try to integrate all these aims in one standard that try to have mainly the georeference information, but also the multidimensional data model, and also consider the optimized access and considering the if and the seek optimized if, and sure the interoperability and based in a standard, no? In the GC standards.
One of the new things could be precisely this data cube approach, because we tried in testbed 20 to try to figure out how to do it in COC, in Cloud Optimized GeoHEIF, and there are some elements that are missing. In GeoHEIF, you can have a multi-band, but what you cannot have is to assign those bands to different dimensions in a multi-dimensional data cube. That capability is not there. So that's one of the things that we could do different, really different in in GeoHEIF. If you ignore the new compression formats and so on that the HEIF format brings. Okay. So what is this one?
This is a little bit more the same, no? It's like the context. What is HEIF, what is GIMI, and what is the geospatial data, no? A little bit more
Yeah, from our point of view, more sensible with this data cube approach. We bring also the mention of the NetCDF and HDF that are more directly multidimensional arrays that can be easily mapped to these kind of structures. So, as we said, the HEIF format has this idea of boxes. And a box could be defined like something that has a header structure based on what is my name, so the box identifier, that is more or less the type of box I'm going to read, and one is the size. And the rest is the content that you know when you know the box identifier that tells you which kind of box is this. Yeah. No, for instance, you can have a box that is called item location box, or in this 4-letter code is called ILOC, and this is going to give you where one of these items that are defined here, and I will describe that maybe better afterwards, where the items are really written in this other box. So in this case, it's kind of an offset, but sometimes it's more metadata of some sort. Yeah. So let's start by the beginning. There are 3 main boxes. The file type box, this is the 4-letter code, and that is mainly a list of brands, they call it, that are kind of a hint of what you are going to find in the file. So with the brands, you can know, for instance, if this is a still imagery or it's a kind of a video or so on. You can also know if this is compatible with GIMI or only with HEIF, etc. These kind of things. The codec. The codec can be inferred from it. Then we have the meta box that, of course, it's called meta box for a reason. This is metadata. And this is where you have or you see this capability of box in a box. No, the boxes are nested. So you have one box that is called meta box that inside can have several boxes. Some of them are really, really interesting because it defines something called item. And items are the base unit where you start, pulling the thread of maybe an image or maybe a video or something like that. So with the item, you will have the item metadata that will be maybe, for instance, expressed in properties in this item property box. Or you can have this item location box, as I say, that it tells you where the actual data is, and some other red properties that you really need to actually understand what you are gonna read. And finally, you have the media data box. That is the media itself. So it's where the image or the video or else is actually stored.
Yeah. Only that one file of this is organized in boxes, but the information is the item and can be one or several items. For example, if you have the image and with the metadata, one item is the image and another is the metadata. And this file has 2 items, no? And can be several items.
So when we started to develop the library, our library, one of the first missions of the library is I will actually detect the items and then accumulate in the items the different metadata the other boxes bring, because that's more convenient for the actual reading of the file that having everything scattered as the format gives you. I mean, the advantage of having the things scattered is, for instance, a property can be assigned to several items. Yeah. So you do not have to repeat this property several times. So there is an advantage in compression, but there is a disadvantage that everything becomes a little bit more messy. So that's how it works. And this is more or less the same, but explained in a different way. And these are the definitions of the brands. And we did this table because one of the difficulties with this file is that in order to have all the necessary information to read, for instance, a still image, you need at least to read 4 or 5 different documents that you don't know which are the ones that are relevant to you, and half of them are ISO documents that you cannot access without paying. Unfortunately, you cannot be sure that what the content that you are looking for is in the file until you buy it. And if you realize it's too late. Come on, it's not the one. So this is kind of a difficulty that you have, and I invited you to read about baseline. Well, testbed 21, one of the documents is called the baseline, because in there we try to accumulate the different definitions of the different boxes that you need to, extract and follow, at least for still imagery, and actually document clearly where they come from. So if somebody else wants to develop a library, he will have the information at his fingertips.
Because there is some boxes that are general, that are defined in ISO BMFF, sorry, and in HEIF also. But there is also another that are specifically for each codec. And for example, if you are using CP 2000, there is another boxes that appears that it's only for this format.
And this is, you were saying, in the testbed 20?
And 21.
21.
No, the one that I was advertising last is the testbed 21. There is one document that is called the baseline.
Okay.
That means what we knew at the beginning. Actually, it's a lie that we knew it at the beginning, but we shouldn't know at the beginning at least. Exactly. So we have been accumulated all these things that we haven't changed. It's just that we didn't know ourselves, but we're there.
So, it's a public document. No, I don't know. It's a
Testbed 21 is not public.
It's not public, but it will be after Helsinki, hopefully.
Yes.
So those documents will be approved in the Helsinki meeting in a month's time.
But if you join the GitLab,
You can, yeah.
Yeah.
If you join the GitLab, you can see all the documents.
Yeah.
Right. So now this nice diagram will tell you how we divided GIMI into different requirements classes. Let's start by the beginning. What is an OGC standard? Let's start by the beginning. What is a standard? No, not so the beginning. But anyway, what is an OGC standard these days? It is actually a list of requirements classes plus the requirements in each class. All requirements are mandatory in a requirements class. The requirements classes are all optional, except if there are dependencies. So this is the way the standards are structured these days. And that creates some kind of a constraint, because if you want to make a single requirement optional, you cannot. So you need to create a new requirements class to put that requirements class inside, this single requirement inside. So this is the way we modularize that. We have 3 requirements in the conformal requirements class that is called the core. Those are necessary, and you can imagine they are very stupid. A GIMI file actually depends on the BMFS, for instance, is one requirement, something like that. Then on top of the core, you have the content ID, and you have the temporal, the atomic time, no?
The maximum time.
International Atomic Time, but
That's right.
for some reason it's in the opposite order when you create the acronym. I don't know why. Those two are defined independently and depend on the core. But when you describe what a still image needs to do, you depend on both. So by declaring the dependency of those two, you indirectly depend on core, but this is not in the standard. I'm explaining this because it took me a while to actually understand how to do it. So sorry for going into the details. Security markings, actually they use content ID, so they need to depend on content ID. And the most important thing for this session, the metadata itself. The metadata describes the images, not the metadata that is necessary to know the number of columns and rows and these things, because those are in the ATEM properties.
Yeah.
We are talking about the typical metadata, the lineage, the data quality, all these things, and in particular the georeference, they go apart. And they are done, at least this is the suggestion of GIMI, they are done in RDF metadata format, and they can be outside the file in a company file they call sidecar, and or can be embedded in one of those boxes that will be particular because it will have a MIME type of turtle. So this is our focus.
Are they mutually exclusive? Like, can you have a sidecar and a bit? Or
That's a good question, actually, and I was thinking about that. I was almost tempted to say they are exclusive in the baseline, but actually there is no reason why they are exclusive.
because I'm saying this because, for example, in the Open API specifications, I think in many of the standards, one of it's not correctly understood. There's a lot of bugs there. So
Maybe, yeah. So in here I was thinking a lot about that, but in the end I thought, well, there is no harm done if you have the metadata inside as well as in the sidecar.
There is no
So
connection.
I will not say anything.
There is not a really connection between
I can confirm that they're not mutually exclusive. You can have both. There's no restriction.
And you confirm restriction. Thank you.
okay.
But and there is no connection inside the file. No?
Yeah.
When you are reading the image file, there is not a place that you write the direction of the
Yeah.
sidecar file.
Yeah, but then what is if they contain information that is
Duplicated.
or
Yeah, contradictory.
yeah.
Yeah. That
I
can
don't
happen.
know.
That can happen.
So the RDF files, it's a set of data. So any sets don't do duplication. So any duplicated data is handled like any other set would handle it. So it's just redundant. It's not.
It's not contradictory, or it's just redundant.
Shouldn't be contradictory.
No, the reason is the use case, right? The only reason that you might have both at the same time is the use case.
Yeah.
Yeah.
So if you have a use case that needs to have both
Yeah, but
inside and outside,
You need
then
to-
you have to be duplicated.
Yeah,
Otherwise, it's just
yes, but contradiction will happen.
Yeah, exactly.
Undetermined.
Contradiction will
But then
happen.
you need
Then
to
you can change
it's
what
like
we
the
do.
parentheses,
Yeah.
no? What you
then
need
the
to follow.
CTTG should just fail
Yes,
the
but not
file.
everyone will run that. So in the wild, there will be data with contradictory
It's uncertain.
metadata. And
One thing.
what should we do in those cases?
One
Yeah.
thing would be to actually define which one takes priority in case of a contradiction. That could be a possibility. By my experience in the OGC defining that, it's kind of scary because we agreed, for instance, that, if I remember correctly, we agreed that in the standards where the schemas had a difference from the standard document, the schemas took precedence.
No, it's not,
And-
it's not what ISO said. I know that some people at OGC said that, but
Yeah.
ISO said the opposite.
Exactly.
ISO said that in case of conflict,
That
the
makes sense.
UML
Yeah.
has precedence.
So it's kind of a mess if you start defining precedences. This
Yeah,
is
but
what
it's
this
the
is what I
reason-
wanted to
it's
go.
the reason why it must be clear. ISO
Yeah.
said that the UML
Yeah.
has precedence.
Okay.
Some people at OGC, I have heard that. Some people at OGC have said that the schema have precedence, but it's not correct according
I will not say if it's correct, and I will not say some people. I believe it's a directive. I believe there is a policy that says that.
It's not correct compared to ISO policy.
Yeah. And maybe it wasn't a good idea, but I believe there is a policy that still says that somewhere.
That's interesting to search for.
Yeah.
But anyway, we have a case of when even the policy are contradictory. So even the policy about what to do in case of contradiction, even the policy are contradictory.
Yes, exactly. So, flashback. 1 year ago, we were sitting exactly in the same place doing testbed 20. And in that particular moment, there was no idea on how to do georeference, so we invented one. Actually, we discussed it for more than 6 months if we needed to use a fine transformation or not. And in the end, we agreed that we will, at least in this document. And this is a document that is approved, and you can download it. That says this, and the thing is, since everything is a box in this kind of files, and it's a binary box, most of them, we wanted to follow that, and we created at least 2 boxes. One is for storing the CRS, and we gave them even a name. This is the MCRS, and that was an item property container box that include the definition of the CRS. I believe we were quite flexible, so we supported these short names that these days they are called unsafe queries because they do not have brackets. If they would have brackets, they will be called safe queries. I really don't understand why a bracket can bring any level of security, but anyway.
So what are the unsafe? EPSG?
No,
without the square brackets, it's considered unsafe.
Okay, so that's unsafe.
That is
Yeah,
unsafe.
Yeah.
Yeah.
But-
If you put it between brackets, they are called safe queries.
but it's
Yeah.
probably more thing for when you are doing a request, a HTTP GET request or something.
What is a
like that,
CRS 84?
Makes sense.
It's
But you are-
unsafe.
Yeah, you,
But
everything inside that is filtered out.
because there is 2 points, and sometimes you can mix with other parameters in the
Yeah, I
request.
believe
Everything
it's, yeah.
to this, as I say, and it's secure. I don't know. It's my explanation.
You know, it's I can explain it in a different way. We started at the beginning by using just numbers, and we realized that was a bad idea. So we added the prefix. While when we added the prefix, we said, well, but the prefix is not semantically clear. So we went into URIs. Those URIs were terrible. So people started to complain about the URIs that were terrible. And we say, well, this fragment of URI could be compacted into, again, some kind of a prefix. But we wanted to say that we were not doing exactly the same, so we put it the brackets, and we call it queries. And then somebody complained about the brackets. Why the brackets? So we removed the brackets, and we became exactly in the same place as at the beginning, but only 4 years later.
Oh, yeah, the URL,
That's a good story.
Now
It is, but it is, unfortunately, it's true. That's the thing. So now what we have to support is a big question mark. Maybe all of it. I mean, where URLs are really annoying. URLs are really annoying when you use key and value pair in a URL because you have a URL inside the URL, and that's really. But
in the standard, you have the URI, or you also support.
No. We support.
we support whatever.
I think
In the
that
standard.
Yeah.
in the test
Well, there is no
language,
standard in the technical report.
Sorry. Okay.
Candidate, I don't know. No, they never arrive at this point, but
Yeah.
we support.
No, we support even more things. We support the well-known text representation of the CRS.
And also JSON, JSON encoding.
And we needed to support also.
The current draft from last year support only 2 encoding. This one,
Yeah.
the URI,
And
and
safe.
anyone no test. The other one.
We We didn't mention
Maybe the URL, I don't remember. What it is.
we didn't accept the JSON representation of the one
It was not done at that time.
Yeah.
It was
Well,
right
it is-
in the
It may be
document.
work
It is
for the
true.
future, but it was not done in current draft.
Okay. Yes. All this discussion is just to mention the CRS. Then, then we need to actually explain. You know, you have a big image, isn't it? Like this one. What I would do is to say what's the position of this corner and what is the position of this other corner. And with that, and knowing the CRS, if the image is geo-referenced, I will say I have everything. The problem is somebody invented this mess about the access order. So these coordinates, you don't know if they are in one direction or the other. Even if they are in latitude, longitude, the image is not. So in the end, we needed to do this affine transformation thingy. Sorry, because I have to take this one. Pots continuar?
And we have to wrap up as well, I think.
We still have a buffer of 10 minutes
Yeah.
if you want to continue. Yeah.
No,
Please.
well, finally, we decided to implement a fine transformation,
Yes.
transformation matrix that it's not you cannot need to know the order of the axis, and you can transform from the image to the map and having the
Just to
coordinates.
explain the issue comes from GeoHEIF. It's because
Yeah.
the EPH database have latitude, longitude, access order, or whatever, and GeoHEIF, for making things more convenient from their point of view, they said when we said that the CRS is 4326, ignore the access order that is in the EPH database and always use longitude, latitude. Actually, it's okay if we want a different access order than what the EPH database said. It's okay, provided that we set that in a non-ambiguous way. And the way that it is defined in the GeoHEIF specification is ambiguous. It's non-ambiguous for simple case like longitude, latitude versus latitude, longitude. But the EPH database also contains CRS on pole area, for example, with direction like south along the 98 longitude and then south along the 118 longitude. What do I swap those axes or not? And what do I do with the engineering CRS? We talk about drone. So in engineering CRS, the direction are forward, starboard, stuff like that. Do I swap? Do I not swap? So to have a specification that said you swap the access order in that condition is ambiguous because it will always cover only a few simple cases and be ambiguous for all other cases. So if we want, we can swap access order, but we must specify that in a non-ambiguous way. And if we just give the corner of the rectangle, there is no way with only that just information to say if we want to swap the access order or not. We need some more data. And one non-ambiguous way is affine transform. So it's one non-ambiguous way. It's not the only one, but it's one non-ambiguous way.
Yeah, and you can see here the negative signs that those the flip of the.
Yes, because there is those two issues, the swapping and the axis direction. Is it not up? Is it not down? Compared to the image, the thing is that the image usually have the y-axis have the opposite direction than the CRS usually, but it's not always the case in our file format. For example, it's usually not the case in NetCDF. In NetCDF, the axis tend to have the same direction. So typically in a NetCDF file, the sign will be positive rather than negative in a NetCDF.
Yeah, this is not a new thing actually. If you remember the wall files that is recreated, they are sidecar files. They have these numbers and
Yes.
numbers too, and they go into this direction.
Yes, it's exactly those numbers. If we look at the wiki page, it's a little bit ambiguous because they call about rotation there. but they are not rotation. It's a mistake of Wikipedia.
Well, they have been called rotation, but they were always zero. I have never seen any.
It's not well. The term on the anti-diagonal are not rotation. They are shear. They are the correct term in English is shear. SHER. So the rotation is, we need to use trigonometry to take out the rotation from that.
Yeah.
So the wiki page, I think they fixed that maybe recently, but at least a few years ago, the wiki page was confusing. But yes, the WAR file is exactly that.
And
GML JPEG 2000 is also exactly that, except that they split the matrix into parts, the offset vector and the origin. But it is exactly this matrix just split into parts.
Yeah, a little bit more difficult to understand than just for numbers and a bounding box, but more precise.
Yeah. Well, this was the approach in the TSV20, and in the TSV21, we follow a different approach.
And the approach is based on, well, we follow. We got another approach, and then we implemented this approach because that was the one. It is based on adding an RDF file into the GIMI file. It is written in Turtle, and it will be much more powerful than just this thing about the georeference, because it is intended to define the semantics of many concepts that could describe the image or even the processes and sources that gave into the result that particular image, what we call the lineage in short. I'm not particularly fan of the RDF myself. This thing about splitting everything in triples, I believe it's killing me. But but anyway, this is just my opinion. It works. There are nice things done in RDF, so I will not complain. We had some discussions if the encoding that we received was exactly the encoding needed to be, and you will get another of those reports that is actually precisely on that. Maybe we can go directly to the next slide.
Not only that it's in Turtle LDF, but the special elements, for the special elements will be used the GeoSpark well.
The GeoSpark well syntax.
And mainly the WKTF literals.
You are going to see that in the example just next, I believe.
This is more requirements in related
This
with
doesn't matter. So let's go to the next one.
And this is some examples.
Yes, this is how it looks like. First thing that I have to tell you, for some mysterious reason, well-known text has no element that is called bounding box. So you cannot do 4 numbers square thingy. There is no affine transformation either. The only thing that we have is an object that is called polygon. So instead of giving you 2 coordinates, I will give you 5 coordinates around the screen in my imagination. Is that better than, for instance, describe an envelope and then provide 2 points?
2 corner points. Yeah.
2 corner points? I don't know. What we did was actually to extract this element from the RDFs that were given to us.
Yeah, but in the document that Simon proposed, there was close approach.
So you will get something as mysterious as this. This is just an extraction of 1 triple. There are plenty of triples in the document. What you have to do, you have a content ID. Do you remember that I said that every interesting thing in the file has a content ID? This is the content ID. And then you look for an element wherever that actually says that this is your content ID, and this is a mysterious number that says this is the content ID. And at the same time, it needs to have a GeoSparkle well-known text. And if you have both, the content ID and the GeoSparkle well-known text polygon, bingo, you have your GeoReference. So this is what we developed. be prepared because it's 2,000 lines of code. No, actually, it's just, relatively simple, and it's complicated because you can have more than one item. So actually, this is a loop on your items. If you don't have content ID, goodbye. If if you have content ID, you then look for this. If you have this thing, I forgot to tell. Since I hate RDF and I like JSON, the first thing that I do is just to convert it. But this is just my trick. I mean, the important thing is here. No, you look for this number. If the ID of this number is the item ID, this is your guy. If not, goodbye. So now you have your well-known text, and now you need a library to actually take the well-known text and split it into the 4 coordinates. There is one out there that works nicely. So it's not so difficult.
We forget something.
I forgot something.
No, it's weak. There is also a way to put the georeference information, the CRS, in this later on. If there is nothing, if you are writing the point directly,
What is this?
it's in the first sample.
Yeah, that thing.
You have the coordinates are in CRS 84, and if you want to express the coordinates in other coordinate reference system, you need to put the URL before the coordinates, the point or the polygon or
This time goes into these kind of brackets. So again, for some mysterious reason that I have no idea. Okay, but there are other possibilities, of course, and we have been doing these possibilities. For instance, in OGC API Common, you describe your collections that are just up here, and you describe the extent, and the extent is actually an array of bounding boxes in this case. And the first bounding box is a global bounding box, and if you have sparse elements, you can have more bounding boxes to define your individual areas. But in this case, it's just an image, so you only need one of them. So that's what here it says. You have a CLS and you have a bounding box. So this is our tradition. And in the coverage implementation schema, this is for coverage, of course. You have this envelope guy that is actually 2x's. And I believe this is what you meant when you say that this is, in some cases, it's split into elements.
It was called offset vector and origin.
Yeah, so maybe this is not the version that has the offset vector as the origin. Or maybe this thing is inside the domain set. So we have plenty of options to actually select.
I think we need to.
And there is no end in this
There's
thing.
no end.
No, there's no end. I mean, I have no idea. This is the thing. I mean, there are advantages and disadvantages. There are people that are more keen into respecting the access order, like him, for instance. There are people that they don't care much, like me.
It's not about respecting access order. It's about being unambiguous.
Absolutely,
Absolutely,
absolutely, and I understand that. There are other people that are really interested in having the metadata in RDF because they are more worried about the concept. So is this a CRS or it's I don't know, the lineage? So it really depends on how you think about these things. And then we have this other problem because sometimes you have an image that is actually rotated in your coverage. So when you are dealing with the bounding box, are you dealing with the square or are you dealing with this?
Again, I cannot resist to point out that it's not a problem with that point transform. This problem disappears.
Yeah, of course.
And you also need future proof because we talk about oblique imagery.
Yeah.
So if you replace the last row 0001, if you replace that by number, you get oblique imagery. And then it's yet another topic, but we can do yet one step further after append transform. We could use Jacobian matrix. So it's another level, but you see it's step by step going to more complex place.
Yes, there's no end. So maybe we can go to the end.
Yeah.
The end is to be continued.
Yeah.
So please come to our discussions. They are gonna start in Helsinki. If nobody votes against, the vote is already running, but it's gonna finish before Helsinki. If nobody votes against the establishment of this GeoHEIF group, maybe I will vote against.
The data has passed, it's improving comment, the problem.
No, this is not. This it requires a TC approval.
Okay.
After the public comments.
Okay.
And this is an electronic vote that is open at this moment. So if nobody vote against, January 1st at 3 p.m., please, if you call, be aware this is not exactly the same time as the Central European time, is another thing. If you are there, go to room B and come and have fun. Thank you.
Unfortunately, we don't have time for questions. We need to.
No, we have,
Yeah.
We have
We
2
have
days. We have 2 days too.
you will have 2 days to resolve the questions. We will. Our intention is work more in introducing new encodings. Well, new for us. I mean, encodings that we haven't developed yet in our client. And for the moment, let's this topic about the georeference settle until we touch the implementation.
You want to implement in the client or you already implemented now? You want,
We would like to implement a couple of uncompressed encodings that probably on the flake that we do not have support yet in our client. And we want to also the AV1, no?
Yes, I think we are trying to implement some other codecs like HEIF and also, and we can try AVC too, and there is the uncompressed have sometimes compression. And
But
we
we
are
are-
trying to implement this compression.
But we are not going to implement the codes. We are borrowing
Yes, you get
the
the
code, the
libraries.
encodings, and put it in the right place and connecting them with our code.
And if we have time, we want to try also to implement that in our map browser. We try to work with the data and make analysis and all this. And we are trying also to work with the values and having the capability to make some analytics.
So
Very good.
doing an Instagram of the
Yeah.
values that you have, these kind of things.
That's too ambitious.
Let's see.
Yeah.
No, but we have the machinery. It's a
Yeah,
question
yeah.
of if we have a couple of quiet days and
We need
maybe we will
to
manage to do some.
Tomorrow.
forget the
You know, you are